Hello all. In this video clip, I will cover section 2.2, the polynomial function. I claim that actually we are seeing polynomial functions a lot. We may just not call them the polynomial function. For example, see the function f of x equal to, say, 2x minus 1. We usually call it the linear function, right? How about this? F of x equal to 4x squared minus 5x, say plus 3. We call it the quadratic function. Similarly, we use the same way to develop the type of function more. Instead of having just x and x squared, we may have a function like this. F of x equal to negative 5x cubed plus 2x squared minus x minus 5. And this is, people use called the cubic function. You kind of try to function have something similar. The construction of the function is what? We have a number times x plus a number. A number times x squared, number times x plus a number, right? So in general, a number times x raised to some power plus another number times x raised to some power x. And keep all the way to the end. And with those type of function in general, we're going to call them the polynomial functions, okay? And by the way, there are two things that's pretty basic and important for polynomial function, which is the exponent. We're looking at the highest degree. So in this example right here, the highest degree is 3. We say that this is a polynomial of degree 3. And those numbers, negative 5, 2, it's negative 1, negative 5 called the coefficient. And a number in front of the highest degree term, then we call it the leading coefficient. And similarly, right here, the quadratic function as we learned before is actually the polynomial of degree 2. And similarly, linear function is no more than a polynomial function of degree 1. Okay? So let me give you a formal definition of a polynomial function. First definition. Since I don't know how many terms it's going to have, so I'm going to write it in the general way. A polynomial function is a function of the form f of x equal to, right this way, a sub n times x to the n plus a sub n minus 1, x to the n minus 1, plus da 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 all the way to a 2x squared, a 1x plus a naught. Those terms an minus 1, and let's do all the way to a0. We call the coefficients. Box that first. Okay, so an minus 1, a2, a0, a1, a0, call the coefficients. Okay, and the ans is called the leading coefficient. We have one condition for the leading coefficient. An cannot be equal to 0. Okay. And number n right here is called the degree of the polynomial. Okay. So technically, we can have polynomial of any degree 1, 2, 3, 4, 5, 1,000, 1,000,000. But most of the time, I probably people tend to study a polynomial with small degree, like 1, 2, 3, 4, 5, around there. All right, and all the other coefficients could be 0 except for the leading coefficient. All right, and let me show you a very special polynomial. This one, f of x equal to a constant, say 5. So you see no x in here. This is actually also a polynomial. They say this is a polynomial of degree 0. Okay, it's a constant. And if you graph this, you're going to see a horizontal line. And among all the special polynomials right here, we have another one that is even more special. F of x equal to 0. Okay, as I claimed before, definition is what? Leading coefficient cannot be 0, except for this one. This one is a polynomial also. All right, a constant. The graph is the horizontal line, the x-axis actually. And for this one, very special, they say some book depends on the writer, because this is polynomial of degree -1, some books say that, or degree -infinity, or degree undefined. It depends on the writer. But special case, and it's pretty trivial, and we can treat it as a very special case, and it's not gonna bother us much. Okay, and that was the definition. And let's make sure that you get it. Let me give you another example. How about this? Example. F of x is equal to 4x to the 5th minus 7x cubed plus x squared minus 2x plus 1. This is a polynomial of degree 5 with leading coefficient 4. And the coefficients are 4, 0, -7, 1, -2, and 1. You see why I emphasize 0 in there? Because actually in here we are missing a term, the x to the 4th term. So formally we should write this way: 4x to the 5th plus 0x to the 4th minus 7x cubed plus 1x squared minus 2x plus 1. And you see all the coefficients coming out. But of course 0 times whatever equal to 0, and that's why people don't write. Just want to make sure that we really understand the polynomial completely. Okay, that's about the definition. Let's move on. Talk about some basic properties of polynomial functions. Two properties. The very first property that we're going to talk about today is the graphs of polynomial function. We cannot graph the whole thing, but we can roughly sketch the graph of polynomial function. Depends on two things: the leading coefficient and the degree. So let me take a table. We have leading coefficient here. We have degree in here. For degree, we have two types of degree: either even degree or odd degree. Leading coefficient, we have two types: either positive or negative. So, by looking at two things, if you have a polynomial with even degree and positive leading coefficient, I claim that the graph will always look kind of like this, roughly. Okay? In other words, whenever you see leading coefficient positive, you know that the graph tends to go up. And if it's even, both ending branches of the graph will be going up. All right? And negative leading coefficient is going to be the flip over of the positive one. So the graph is going to be like this. Cut up. Okay? And for odd one, positive leading coefficient, the graph is going to look like this. And of course the other one is going to flip over the x-axis like this. Okay? Depends on the degree of the polynomial. The graph may be wiggling more or less in the middle. The higher degree, and the graph tends to be up and down more. All right? But in general, those graphs are going to fall into 4 cases that way. Let's check it out. What we learned before is quadratic function. Example. Say f of x equal to 3x squared minus x plus 5, for example. Let's talk about this in terms of polynomial. This is a polynomial of degree 2 with leading coefficient 3. Look here. Degree 2, even. Leading coefficient 3, positive. And you know, this is a problem that looks like this, upward, right? On that case right here. Okay? And of course, if you have a negative, upside down. And if you have something like degree 1, a linear function, f of x equal to negative 2x plus 1. This is a polynomial degree 1, leading coefficient negative 2, degree 1, odd number, leading coefficient negative number, the graph tends to go down. Okay? That is the first property. Second property of polynomial functions. We'll talk about actually three things at once. All right? I'll be talking about zeros, linear factors, and the x-intercept. Second property. Zeros, linear factors, and the x-intercept. Alright, so let me start with an example. Let's go with a simple one, easy one. Say f of x equal to x squared minus 4x plus 3. A very simple example. This is a quadratic function or a polynomial of degree 2 with leading coefficient 1. Okay? Now, can we factor this out? Of course, yes. F of x, factor this out, is going to be x minus 1 times x minus 3. Let's talk about zeros. There are two values in here. If you plug in for x, you're going to get 0 come out. Let's try x equal to 1. Plug in x equal to 1. You got what? F of 1 is 1 minus 1 times 1 minus 3. 1 minus 1 is 0 times whatever is 0. So this is equal to 0. Since you plug in x equal to 1, you get 0 come out. You say that x equal to 1 is a 0 of the polynomial f of x. Okay? Because the input x equal to 1 gives you 0 as the output. Similarly, x equal to 3, when you plug in, you got f of 3. It's going to be 3 minus 1 times 3 minus 3. And so 3 minus 1 is something, times 3 minus 3 is 0 right here. Something times 0 is 0, and you have x equal to 3 is also another 0 of f of x. Okay? So what is the 0 of the polynomial? 0 is the value of the input, such that when you plug in, you get 0 back out as the output. Okay? Next, we talk about linear factors. And of course, when I put three terms together, they are related. What is a linear factor? You guys see in here, we have x minus 1 as a factor. When you plug in x equal to 1, you got 0, right? X minus 3 as a factor, plug in x equal to 3, you got 0 come out. So a 0 will always come with a linear factor. If the polynomial have x equal to 1 as a 0, then it will have x minus 1 will be a linear factor. And similarly, it's going to have x minus 3 as another linear factor. Okay? You see there you go. It's going together. If this is a linear factor, then what? We'll plug in x equal to 3 right here. You got 3 minus 3 equals 0, right? And then what? X equal to 1 is a 0, and what? X minus 1 will be a factor, because 1 minus 1 will be equal to 0. Are we good? All right. And what about the x-intercept? Remember what we talked about the intersection before? To find the x-intercept, what do? We plug in y equal to 0, we solve for x, right? So in here, when x equal to 1, y equal to 0, another word. What? 1, 0 is a point on the graph. What is it? Y equals 0, so this x equal to 1 will be the x-intercept. And similarly, 3 in for x, you got 0 out for y, so those 2 points on the x-axis, so those are the x-intercept. Or x-intercept. And you guys see that 3 items are going together. Whenever you have a real 0, that 0 you know the linear factor, and graphically you know the x-intercept. How about another example? If say you don't know the whole thing, but you know f of x is some kind of polynomial, and you know that f of negative 2 equal to 0. What does it mean by this? When you plug in x equal to negative 2, and y is equal to 0, right? So negative 2 in, 0 out. You say what? X equal to negative 2 is a 0 of the polynomial. Okay? And even though you don't know everything about this function, but you know for sure that it's going to have a factor of x minus negative 2, which is x plus 2. So x plus 2 is a linear factor. Means what? F of x is going to be equal to x plus 2 times something. Okay? There's a factor times something else. Let's call it like g of x. Not a function. Okay? And then the x itself is what? Let me erase this a little. Negative 2 comma 0 will be the x-intercept. Okay? In the next section, we're going to learn more about g of x right here. But for now, I try to emphasize the broadly right here. Whenever you know 0, you will know a linear factor, and you know the x-intercept. Okay? Even though you still don't know everything about this polynomial. But at least, you know it has a factor. It means what? F of x can be written as what? This linear factor times something else. Alright? And you know for sure that you grab that, you're going to intersect the x-axis at the point negative 2 comma 0. Okay, that is the most important part in this section. Let me move on and talking about the graph of polynomial. Let me just randomly draw a graph, okay? We'll talk about the turning point, number 3, turning points, local max, I mean. Say you have a polynomial, just draw it randomly, okay? If you trace along the graph, see what happened. The graph tends to go down, the bottom go up. So if the graph go down to go up, the point right here called the turning point. Similarly, if the graph tends to go up and go down, this point right here called the turning points. All right. So the turning points are either local max or local mean. I say locally because within that little interval, it's going to be the lowest point or the highest point. It may not be the lowest or the highest point for the entire graph, but locally, those are local max or local mean. Okay, called turning points. And of course, we may have more. You see this higher degree polynomial, you may have more turning points. Next question. How many turning points you may have in a polynomial function? Well, the answer depends on the degree. And I claim that a polynomial function of degree n will have at most n minus 1 turning points. Turning point. Okay? So polynomial degree 5, you know that it's going to have at most 4 turning points. Polynomial degree 1000 going to have at most 999 turning points. So we have a polynomial degree 2 quadratic function. It has exactly 1 turning point. Degree 2, 1 turning point equal to a parabola, either upward or downward. You see, just 1 turning point. What about n equal to 1? Polynomial of degree 1. Going to be no turning point because degree 1 is going to be either a line. It will be go up or go down. Never turn back. Okay? Polynomial of degree 3. You may have at most. Okay? Emphasize at most. So n equal to 3, you may have up to 2 turning point. Up to 2 turning point. could be like this, or could be like this, okay? Or degree 3, you may have this, which is no turning point. So how do you figure out? Well, we're going to get to count 1 to figure out how many turning points we have. Polynomial of degree n will give you at most n minus 1 turning point. And another thing about a turning point is this. The number of turning points will be different by difference of 2. It means what? If a polynomial of degree, say 5, it may have 4 turning points, 2 turning points, or 0 turning points. Polynomial of degree 6, it may have 5 turning points, 3 turning points, or 1 turning point. Okay? Now, let's extend the concept a little bit more. What can we do with a turning point? All right? What can we get from it? What if you have an even degree polynomial and even? We know that for the first priority we learned if the degree is even, then the polynomial could be upwards 2 branches like this or downward. All right, even. So if n is even, the graph of polynomial is going to fall into either the first case right upward or the second case outward right here. And I claim that if n is even, you see, those two things we know for sure is going to have one thing, which is the minimum, absolute minimum or maximum. See why? This graph going down, right? And it may change a little in the middle, but at the end, it's going up. Eventually, you're going to hit the lowest point, which is the minimum. And the other way around, we flip it over, so it's going to have a maximum. Degree